So in the last couple of months, we've seen R410A go bye-bye. We are currently now dealing with R454B as the current refrigerant mostly used in all equipment. With R454B as a mildly flammable refrigerant, we are now dealing with the leak sensors and dissipation boards that are required on any equipment installed with R454B refrigerant. A while back, we did a video on dissipation kits and shared with you a lot of the wiring diagrams associated with the kit. But recently, tech support has received a lot of calls regarding wiring up a dissipation kit to various types of equipment. So in this video, we're going to go over some of those wiring diagrams and provide you with a library of diagrams that you can use when installing R454 equipment. So the dissipation kit consists of a sensor that needs to be mounted at the indoor coil, a sensor wire harness, a control board, and a housing, and then the power wiring harness to connect it to the system. So let's take a look at the dissipation kit and the wiring of these kits. So just as a review, let us look at the sequence of operation of dissipation and what it's supposed to do. First of all, the sensor that is mounted at the coil is going to trigger at the level of 20% of the refrigerant leak. It is then going to signal to the outdoor unit to shut off the outdoor compressor, and then it's going to activate the blower to run at full speed to dissipate the refrigerant until the level falls below the required 20%. So any system with R454B refrigerant must have a dissipation control installed in it to detect any refrigerant leaks. So you will be installing a system either with a dissipation control factory installed, or you will have to field install a dissipation control system. The following wiring diagrams will help with any wiring you will have to do on a dissipation system. We recommend that you take screenshots of these wiring diagrams and make sure all of your installers and technicians have them when installing a Carrier Bryant system with R454B refrigerant. At the end of each wiring diagram slide, we will pause the program so that you will have ample time to take a screenshot of the wiring diagram. So here's a wiring diagram for a single stage furnace with a single stage outdoor AC. Pretty much straightforward wiring hookup. In this case, you will have the Y signal going through the leak dissipation board in order to shut down the outdoor unit once the dissipation board detects a leak. As with all these diagrams, the G terminal from the furnace is run through the dissipation board so that once the outdoor unit is shut down, it can activate the blower at full speed to dissipate the refrigerant leak. In this slide, we have a two-stage furnace with a two-stage outdoor air conditioner. So of course you will have your Y1 as well as your Y2 signal going to the outdoor unit. Again, you will have your Y1 signal run through the dissipation board in order to shut down the outdoor unit in case of a leak. And then the G terminal will work off the dissipation board to activate the blower during the dissipation cycle. In this case, we have a furnace with a single stage outdoor heat pump. Pretty much the same hookup as an air conditioner except for the heat pump hookups. We have, of course, the W signal to energize any heat strips or auxiliary heat you might have, as well as your Y signal with your O for reversing valve operation. Again, the Y signal will be interrupted anytime there is a leak detected by the dissipation board, and the G terminal will be activated to bring the blower on to dissipate the refrigerant leak. Here we have a furnace with a two-stage outdoor heat pump, where we have our Y1 signal and Y2 for second stage. Again, we have the W for an auxiliary heat, and the Y signal being interrupted in case there is a leak, and the G circuit energizing the blower to dissipate the refrigerant leak. In this slide, we have a communicating furnace with a non-communicating single-stage outdoor air conditioner. So the outdoor air conditioner is a non-communicating, just standard air conditioner. The thermostat is wired from the furnace control to the common and the Y1 to operate the AC. The communication goes through the leak dissipation board, which will activate the blower through the dissipation terminal on the furnace control board, and the outdoor unit will be deactivated through the communication ABCD to the leaked dissipation board, as well as energizing the blower to dissipate the refrigerant leak. So now it gets a little more complicated with a communicating furnace combined with a non-communicating outdoor two-stage AC or heat pump with a NIM module. Any Carrier Bryant dealer should be well familiar with the NIM module as it is used on a lot of our equipment. So the NIM module is used anytime you have a two-stage outdoor AC or heat pump that is non-communicating. The ABCD connections off the furnace and the dissipation board will land on the NIM module at the ABCD connector. Then the standard wiring for the thermostat is done from the NIM module to the outdoor non-communicating heat pump or air conditioner. Also, the A2L dissipation terminal is connected to the out terminal for the G on the dissipation board to activate the blower anytime there is a leak detected. So since there's been a lot of confusion about when a NIM module is needed, I thought I'd throw this slide in, and I would encourage you to take a screenshot of this slide and have it in your file in your library so that when you're faced with a question of whether you need a NIM module or not, you would have the answer at your disposal. You will see from this chart that anytime that you have a furnace with an outdoor two-stage AC or heat pump that is non-communicating, you will need to use a NIM module. And then if you're installing a non-communicating outdoor unit with a fan coil, you will need a NIM module anytime it is a two-stage AC or a two-stage heat pump. So please take a screenshot of this so that you have this information available to you whenever you need to make a decision whether you need a NIM module or not. So this is kind of to reiterate some of the wiring diagrams that we've looked at already, but since most of the confusion comes in on communicating units, I thought I'd go over this with a little more pictorial. That when you have a communicating outdoor unit, the dissipation board is tied in with the ABCD connections. And then you have to make sure that you tie in the G terminal if your furnace has a dissipation terminal so that it will be energized during the dissipation cycle. Then with a non-communicating outdoor unit, it ties in through the normal Y and C terminals, and you need to make sure that the dissipation terminal is tied into the G terminal in order to activate the fan whenever the leak detection is activated. When you're dealing with a fan coil and a communicating outdoor unit, The outdoor unit is, of course, connected by the A and B connection and sometimes the C if you have a communication issue. And make sure that your dissipation board is tied in with the ABCD connection to control the dissipation cycle. When dealing with a non-communicating outdoor unit, it is hooked up by the standard thermostat wiring off a NIM module, which we have already gone across, and we have supplied you with a chart that shows you when to use a NIM module with non-communicating outdoor equipment. Then, of course, on your dissipation board, you are going to have a LED light that will flash up to 8 times. And with the flash code chart that is usually supplied with the unit, you will know what is going on with the dissipation control. And again, we would encourage you to take a screenshot of this and have it at your disposal, as every R454B system will have the LED light that will give you a diagnostic flash to tell you what is going on. So when you're servicing R454B units, you should have this chart with you at all times. If you enjoyed this video, click the like button and subscribe to this channel to make sure you don't miss new videos each week. Thank you for supporting this channel.